talk about the unit circle. First of all, we begin with the Cartesian plane. So the Cartesian plane just means graph. It's a fancy word named after René Descartes, who was a French mathematician. So it has an x and a y axis. Everybody familiar with that? Okay. Then we're going to look at a circle. Anybody want to explain what a radius is? Half of the what? Starts with the D. I know what you guys meant. Yes, diameter. Okay. It starts the center of the circle. Any point in the center to any point on the circumference is the radius. So you could move that radius around however you wanted to. So now what we're going to do is put that circle on top of the Cartesian plane. So in other words, take that circle and put it on a graph. You generate you generate 5 points, okay? The first point is the point in the middle of the circle, which is 0, 0. Then we have a point on the right, which is r, 0. So let me explain what that is. Let's say the radius is 4, okay? Well, since the radius is 4, then this first point would be 4, 0, the x value followed by the y value of 0. Next, the next point would be 0, r. So the x value would be 0, the y value would be whatever your radius is, and then these other 2 points would be negative x because it's to the left and negative y because it's down at the bottom. Okay, so usually with the unit circle you start down here. Right? It doesn't, I don't know why, but it's kind of like, it's just a point of reference, okay? So the starting point on the unit circle is right here on the x-axis. So let's, again, say the radius is 7. The starting point would be 7, 0. Okay. So we will now travel from the starting point right here to a new point. Now you can make that point whatever you want. You could make the point down here, and this red line is your arc, or your angle, would be bigger, okay? And if you go all the way around, your angle would be 360 degrees. We've talked about degrees before and where they came from. But anyway, wherever you stop, that has a point x, y. And we're going to label this arc theta. Okay, this is the Greek letter theta. So number 5 on your worksheet, an angle is nothing more than the measure of a circular arc, ARC. That's all an angle is. An angle is actually just a piece of a circle. The biggest angle you can have without repeating itself, right, or once you repeat itself, is 360 degrees. So this angle right here, if I had to guess, be about 60 degrees. But what we're going to be learning today is what a radian is and how to convert from degrees to radians. The input of the unit circle is an angle. Okay? Number 6, by the way, is theta. You can just draw that symbol out. The output of the unit circle is a point. So basically, this is how it works. You draw some kind of arc starting at this point. Maybe you want your arc to end right here. Okay? The output would be whatever that point is on the circle. It has values x, y. So you can imagine there's infinitely many points on the circle. I mean, imagine 22.5 degrees would have its own point. 90 degrees would have a point. 270, whatever, right? They all have x and y values. What I want you to see the most is that this is just an angle. Whatever arc you pick is the angle. All right, let's keep reading. The ultimate goal is to write each point in terms of the radius of the circle. We do this by drawing right triangles and using trigonometry we've learned. Okay, so we've learned 30, 45, 60 triangles. And again, we're not going to dive so much into the triangles as we are the angles. So number 7, what we're going to do is begin to draw the triangle inside the circle. And the answer to number 7 is it's formed by the radius of the circle. So this will form the hypotenuse of our triangle. We'll look at that in a second. And this is how we figure out points on the unit circle, using triangles. Okay, so moving on from there. So basically at any point on the unit circle, you can draw a little triangle. Okay, we'll pull up an app in a second, show you guys kind of how that works as the point goes around. But for number 8, the height of the triangle can be found using the y value, or the y-axis. And number 8, the width of the triangle can be measured using the x-axis. So basically the way we figure out all the points on this circle is by using the x and y values. It is kind of complicated because you have a small triangle within a bigger circle where a point can be basically dragged all the way around the circle. But what we want to really get into is radians. So let me just ask you this, and basically, how can we compare this radius with this angle? How many times does this radius go into this angle? So think about that. If you were to take a piece of string and lay it over this arc, right, it would have a certain length if you pulled that string out. How does it compare to this radius? That's what we're getting at today. The unit circle is a function. The input of the unit circle is an angle. The output on the unit circle is a point. I don't think that's on the worksheet.
Why do we care, though? Like, why do we care?
Let's keep going. So we've already answered all these questions. Let's go to number 10. When the angle measure equals 0 degrees, the height of the triangle is also going to be 0. Okay, again, I'm going to pull up an app and show you guys what that looks like. Let's go back to the picture and answer the rest of these questions. In the second, third quadrant, the width takes on negative values. Why? Because you're to the left of y-axis, so x is negative. So number 11, negative values. Yes?